Welcome to this Class 11 chemistry practice set, focusing on the photoelectric effect. This video contains 15 multiple-choice questions. Choose the correct answer for each question. Question 1. The photoelectric effect was explained successfully by A. Rutherford, B. Bohr, C. Einstein, or D. Thomson. Question 2. Photoelectric effect refers to the emission of A. Protons from a metal surface, B. Electrons from a metal surface, C. Neutrons from a metal surface, or D. Positrons from a metal surface. Question 3. The minimum frequency required to eject electrons from a metal surface is called A. Resonance frequency, B. Threshold frequency, C. Critical frequency, or D. Wave frequency. Question 4. If the frequency of incident light is less than the threshold frequency, then A. Electrons are emitted slowly, B. Electrons are emitted with low energy, C. No photoelectrons are emitted, or D. Metal melts. Question 5. The energy of a photon is given by A. E equals Mach 2, B. E equals h nu, C. E equals mv2, or D. E equals 12 mv. Question 1 from JEE Main 2020. The energy of a photon having frequency $nu$ is A $h/nu$, B $nu$, C $nu$, C $nu/h$, or D $hc$nu$. Question 2 from NEAT 2019. The minimum frequency required to eject electrons from a metal surface is called A. Resonance frequency, B. Threshold frequency, C. Critical frequency, or D. Limiting frequency. Question 3 from JEE Main 2021. For a photoelectric experiment, if the intensity of incident radiation is increased while keeping the frequency constant above threshold frequency, then A. Kinetic energy increases, B. Number of photoelectrons increases, C. Work function increases, or D. Threshold frequency decreases. Question 4 from NEAT 2020. Einstein's photoelectric equation is A $nu equals phi plus Ke underscore max $, B $E equals mech squared $, C $PV equals nRT $, or D $Ke equals 1/2 mv caret $2. Question 5 from JEE Main 2022. The work function of a metal is A. Maximum kinetic energy of emitted electron, B. Energy required to remove an electron from the metal surface, C. Total energy of an atom, or D. Energy of a photon. Question 6 from JEE Advanced 2016. Photoelectric effect supports A. Wave nature of light only, B. Particle nature of light, C. Dual nature of matter, or D. Nuclear model of atom. Question 7 from NEAT 2021. The SI unit of Planck's constant is AJS, BJ/S, CJM, DNS, or E kilogram m. Question 8 from JEE Main 2023. The maximum kinetic energy of photoelectrons depends upon A. Intensity of incident light, B. Frequency of incident light, C. Surface area of metal, or D. Temperature. Question 9 from JEE Advanced 2018. For photoelectric emission, the stopping potential is used to determine A. Number of emitted electrons, B. Maximum kinetic energy, C. Threshold frequency, or D. Intensity of light. Question 10. NEAT 2022. If the frequency of incident light is less than the threshold frequency, which statement is correct? A. Electrons are emitted slowly, B. Electrons are emitted with low energy, C. No photoelectrons are emitted, or D. Metal becomes positively charged. Numerical MCQ 11, JEE Main 2021. The energy of a photon of frequency $6 times 10 caret $14 Hz is approximately what value? Planck's constant is $6.63 times 10 caret minus $34 Js. Choose from options A through D. Question 12, NEAT 2018. The threshold frequency of a metal is $5 times 10 caret $14 Hz. Light of frequency $4 times 10 caret $14 Hz falls on it. What happens? A. Photoelectric emission occurs, B. No photoelectric emission occurs, C. Emission depends on intensity, or D. Metal melts. Assertion reason type question 13. Assertion A. states photoelectrons are emitted instantaneously when suitable radiation falls on a metal. Reason R states light energy is transferred in the form of photons. Select the option that best describes the relationship between A and R. Assertion reason type question 14. Assertion A says increasing intensity increases the kinetic energy of photoelectrons. Reason R says kinetic energy depends on frequency, not intensity. Choose the option describing if both are true or false. Previous year conceptual challenge 15. Two radiations of frequencies $new_$1 and $new_$2, where $new_2 greater than $new_$1 fall on the same metal, producing photoelectrons. Which statement is correct regarding the maximum kinetic energy?